Today we're going to talk about one of those situations in which our data file is huge after we truncate a huge table. I'll give you kind of an example of this, but before I give you an example, I'm going to actually have this process start now because I don't know how long it's going to take. So I'm going to create a table with 3 columns, millions, millions plus 1, millions plus 2, and then I'm going to basically insert, as you can see, the begin value, 1 second, and I'm going to increment it equal to begin plus 1. And what's going to happen basically is I'm going to be storing begin as it begins to increment in each of these columns. So there's going to be 1, for instance, the first time around, 2, and then 3, and then it's going to go around and around, and it's going to go around for 2 million times. So this may take about 5 to 10 minutes to do, which is why I'm going to go ahead and do it now. So just a brief story, and for the record, the million plus 1 is kind of a joke. When we were kids, we'd always compare, well, I have $1,000,000 plus $1 or something like that, and that's where I get that from. But one time I was working on a dev database. Now this dev database was not something that we were using in production. It was not something that we were planning to use in production. It was purely for development purposes. And the other thing as well about the dev database is that we didn't ever back it up. So like anything important that we discovered by just playing around and testing, we would keep on things like GitHub or we would keep code among ourselves. In fact, I have another database that's like a dev database solely for functioning code and examples. Well, so this database was unimportant. And the reason why I mention that is because I'm going to kind of show you guys some tricks today of some things you can do with the database or with, shrinking data files and what happens. But don't do it in production. Don't do it in a testing environment. Don't do it. Do it in an environment that you would never back up. You don't want a BAK file for this database. There may be exceptions in certain environments, but you need to know a lot, and there's no way I could explain everything in one video about this. This is just going to be demonstrating kind of what happens. So the way that I have this database set up, I call this database Crash It. I'll show you. Is that usually with my databases, I have them grow while that's loading. Pull up the properties. I have them grow automatically by 5 meg. I'm sorry, not this database I do, but I usually have them grow by meg. I never have them grow by percent, because think about it, as the database is getting bigger, for instance, if you do 10%, what's 10% of 1,000? What's 10% of 10,000? I mean, that's going to lead to exponential growth, which could be incredibly bad. But then again, in certain environments, that may be something useful. And then usually I have crash it MDF and then crash it _log LDF. This is just my naming convention, and the reason why I do it is so that I can kind of make that assumption on any database that I'm responsible for. Now you'll notice the 5 meg growth. So it has unrestricted growth and it's growing at 5 meg. So if you look at it here, this right, let me make sure you can see this, but this right here is our MDF file. This is under the data, and you can see that it originally started out at 3 megabytes, but it's growing in 5 megabyte increments, because what's happening right now is there are these values being inserted into this table, and so this table is growing and growing and growing, and then as it's growing, it's adding more space to the disk, in the sense that the MDF file where the data are stored is growing. So you'll notice it just jumped to 23. And that's why it's growing in 5 megabyte increments. And one of my other databases, as a case in point, just for testing, I have it grow at 1 megabyte. But generally I either do 100 megabytes or a gig, or depending on the environment, when you're dealing with a big data environment, the database may grow at something along the lines of 5 gig. For instance, just as a case in point with stock data where I work at a financial company, we have, like 6 or 7 billions of rows, a day. That's a huge amount of data. So, and as you can see, this query is still going along here. And this is kind of the reason why I wanted to start that as early as possible. So what happens when you have a huge table as a case in point in this one story. I had 500 million rows of data, but out of that 500 million rows, we only needed 22 rows of data. And some of it was because we had to aggregate some of it was just peculiar data out of the entire data set. But we had to do the entire import. We couldn't get that data any other way. We had to actually do the import in order to get what we needed. So what would end up happening is we would truncate this huge table, right? I mean, this table would be populated with 500 million rows, and then we would wipe it out, get the 22 records we need, and then wipe it out, I'm sorry. And so when you have something like that, especially in this sole dev environment, that you're not backing up that database, and you're using that dev environment for the kind of trashy things like this, then you might notice that your data file, kind of like this data file you see, which is growing larger and larger and larger, your data file is massive even after you truncate the 500 million row table. And let's say all the other tables may have as much as, let's say, 1,000 rows, and there's only 20 other tables. But it's still consuming a huge amount of megabytes on actual disk space. And so the reason is because when you truncate the table, as I'll show in a second, when this finishes, these inserts here finish, it is not going to reset the size of this MDF file. And when we look at the MDF file, it'll tell us the space available and whatnot, but it's not going to reset the size of the MDF file when we truncate the table. And that's why I say it depends, because you have to remember, and you can Google it and you can look at other sites and they'll tell you, oh yeah, you could do, DBCC shrink file, and I'll show that example. But the reason why you don't want to do that in production is because that could lead to data fragmentation. That may lead to poor query performance. There are all kinds of potential things that could go wrong. So if it's a production environment, you want to first of all make sure that whatever you're going into, your production environment, whatever your strategy is going into there, when you have a data file growing out of control, and again, I would never be inserting 500 million rows of data just for 22 rows of data in production unless clients needed the 500 million rows of data. So that's why these situations are kind of exceptional, and they're fun to play with, and it's a good way to learn, but it's not something that I would recommend at all in terms of production. You want to make sure your production data are up to speed. Just as a case in point, on this other machine, I was inserting 10 million rows of data, and it takes 28 minutes to do. So these are not the fastest drive, though this computer over here has a SSD. So that means 2 million rows. If that was actually divided by 10, it should actually already be finished. So these drives are slower. And that's SQL Server 2012. Okay. So while that's going on, I'm going to do this over here. We can also get information about the name from this query. What I loaded in the other, when I loaded the properties, we can get that information from here. You can see the log and the data file. And by the way, the same applies to the log. In this case, the log, give me 1 second, is not growing above what it's at. But you can get in a situation in which your log is growing like crazy, kind of like what we see. I mean, we're right now at 50 meg, and remember the initial database size, or 55 meg basically, the initial database size was only 3 meg, and then it's growing in 5 megabyte increments. Well, the same is true with the log. What was it, about 3 weeks ago, one of our logs on one server of ours grew to, I mean, this was within a couple of minutes, grew about 17 gig. And then everybody panicked, and the system the system admins had to come in and take care of the situation. But that was, there were processes going on, a lot of transactions, the log grew, and so again, do not ever do shrink log. You can go out and find it, and you can say dbcc shrink file, and you can put in the log name and use that. But I would highly advise against that, because again, it may not be applicable to your environment. That's kind of an easy solution that could create a huge mess in the long run. So as you can see, we're right now at about 65 megabytes. And this is going to 2 million rows, or the final value will be 2 million. And that's in 3 different columns. So, and again, this is something too as well, depending on your environment, you don't want to test. And the reason why I say that is because this can also create a mess. This would create a serious mess if you actually had an environment that other people were using a lot of. So that's why having a dev environment kind of in the middle of nowhere is really useful. So just on this other database that I inserted, and you can't see it on the screen because we're still waiting on this one, I inserted 10 million rows of data. Kind of similar to this. The difference is I changed this value to 10 million. And it currently is at basically 1/4 of a gig. That's where we are in size. So this table has 10 million rows of data for 3 columns. So if I truncate the table and I look at the database again, and I look at the size, I will notice that the size of the database is still about 250 megabytes, or basically 1/4 of a gig. However, what did change is the space available. Whereas before the space available was about 5 megabytes, now I have 226 megabytes available out of that basically 255. Okay, so we finished up over here. Good. So I can show you now on this computer. All right, so let's look at our database. Show you what I was talking about. Now notice we have space available. We have 5 meg, right? The size of our database is 74 meg, and we can verify that. You'll see 74 meg. Okay? So if we truncate the table, we've actually wiped out all the data. So we just truncated the table. Now let's look at our database. We have 71.81 megabytes available. 79 megabytes is the size of the database. Now, I know that there's no way that the people watching this know, but I will say, by the way, notice our log grew too. It was at 124 and it's now at 6. So I realize that it's one of those things where you don't see, but there are no other tables. The only table in this database is the millions table, and actually I can prove that actually. Select star from sys.tables. And of course this is going to bring back that one table. So there's only one table in the database, and we just truncated it. We just wiped out all the data. So there's no data in the table, but yet the size of our database is 79 megabytes. So again, we can get the database information from here. Let me show you kind of what we're looking at. You'll see rows, log, there's the name, there's the physical name, and you can see the size, the max size, and then the growth. And you'll probably notice that that's measured differently. Okay, now, and again, do not do this in production unless you know for a fact that this applies to your environment. So if your boss gets mad at you for doing something, you're like, no, I saw this video on YouTube and he said do this. I'm going to be like, actually, I didn't say that. So do not do this in production or QA. You can do this in a dev environment that like only you have access to, or something that you want to experiment with at home. So we're going to shrink the data file, this MDF file right here. And again, let's look at before we run this to show you what's going to happen. This is the size, this is the space available, and we are going to shrink this data file. And we know, remember that we have one table in the database. We populated it with 2 million rows of data. We deleted all the rows of data. We truncated the table, so everything's gone. And the size of our database was still high. Now the space available was high too. I mean, before the space available was very narrow, and then all of a sudden we had all this space available. But let's look at the size of our database. Notice the size of our database drops to 7 meg, and the space available is at 0.13, I'm sorry. And of course that goes back to, it's growing in 5 megabyte increments. So once it got a little higher than the space available, the size would jump up 5 meg again. And then if we go to our, that's our data file, look at where we're at. We're at basically 1 meg, 1.4 meg. So that shrunk the file. How is that useful? Well, going back to my story about the 500 million row table, I think I had about 10 other tables, and they didn't have more than about 1,000 records each. And so that 500 million row table caused the data file to grow huge, which then kind of prevented me from doing anything else on the database because there was no disk space. So this is where shrink file was useful, because that was not a database we were backing up. It wasn't important. I could have even dropped the table. It wasn't important to keep. It was not a database that we were running in production whatsoever, or that we were even running in a QA or pre-production environment or a pre-production environment. It was a dev database that's just kind of out there. So this is something that you can use kind of in your experimentation, but I would highly avoid and caution anyone away from using this in production unless you know that DBCC shrink file is appropriate for your environment.